All right, so I want you to program something, something simple today, right? And I was thinking, let's actually code some stuff in Python, right? So because Python is a simple language, right? It's going to be fun and everything. And I was thinking, what do we need to, what can we program in Python, right? What can we program? And I had this idea in my to-do list to do something with a Java bytecode. Right, because I remember somebody suggested that to me on Twitter, right? And so basically, try to make a simple interpreter for the JVM bytecode or something like that. And to do anything with the Java bytecode, you need to first learn it. And the best way to learn, I think, like any bytecode, is to try to parse it, right? So once you're able to parse the bytecode, you should be able to generate new bytecode. And since you're able to generate new bytecode, you can do all sorts of things. You may create a language that compiles to JVM bytecode, for instance, because you already have machinery that can do that. Or maybe, I don't know, you can do something else, right? So I was thinking maybe today I'm going to spend some time writing a simple parser for JVM bytecode. Keep in mind that I know nothing about JVM bytecode at all. Even though I worked commercially as a Java developer, but I don't really know how the Java bytecode works. And what's interesting is that for a Java developer, it's probably not necessary, right? So the Java runtime doesn't really want you to know this kind of thing. You're supposed to just shut up and do your work. Right, so that's basically the ultimate Java experience, right? So yeah, to be able to parse Java bytecode, right? To be able to parse the Java bytecode, I think the first thing we need to do, we need to generate some bytecode. So let's go ahead and do that. So let me go somewhere to Zosin. So we have a Python, right? We have a Python program, a Python script that parses JVM. So how can we call that? So what's going to be a good name for such thing? Python, Java, Python. Okay, so Python, because Python is already taken, right? So I'm gonna call it Python. Python. Right. So and let's create a main script. Right. Since we are in 2022, I'm going to be using the Python 3, right? Because that's what you're supposed to use in 2022, right? User bin environment Python 3, and in Python 3, if I remember correctly, the only difference between Python 2 and Python 3 is instead of writing print hello world, you write this stuff with parentheses. This is literally the only difference, and this is why they created a completely new version, completely backward incompatible with the previous was, because this thing, the print not having parentheses, annoyed Guido so much he had to break millions and billions of lines of code bases just to get rid of that. He was annoyed so much he couldn't. I'm joking, actually, there's way more differences between them, but you get the point, right? So so yeah, I know that they're completely different, I'm just joking. So let me see. So I'm gonna make it executable, and let me try to run this thing and see if it's actually hello world. There we go. But first we need to generate some bytecode. To generate some bytecode, we'll have to do something pretty nasty, not gonna lie. We'll have to do something pretty fucking nasty. We'll have to program in Java. Alright, so who remembers how to program in Java? I don't fucking remember how to do that. But remember that you have to do something like public class main, then public static void main string args, and then you have to do system out print ln hello world, and there you go. Just compare this concise small hello world with this. What is even that? Like, look how much code you have, and look how small Java program is. Just, they are not even comparable. Look how tiny it is. It's just like so concise, so small. Anyway, so how are you supposed to do that? How are you supposed to compile these things? So I don't even remember. Do I have so something like Java C where? Is it where or is it which? I don't remember. I don't even have a Java C. I think I have it somewhere in OPT. Just a second. Yeah, so I have yeah, there you go. I have a JDK, which is Oracle JDK, by the way. Oracle JDK, not some open JDK, it's Oracle JDK. So the JDK that was developed by a huge company with a lot of budget that can hire a lot of smart programmers, not some crowdfunded stuff. I'm joking, by the way. But by OpenJDK, as far as I know, it's also developed by huge corporations, right? It's I think it's developed by Red Hat. So yeah, so it's pretty much the same. So all of the big corporations, they control open source. If you think open source is freedom and collaboration, no. All of the open source is controlled by corporation essentially, and it's basically a scheme how to exploit enthusiastic young developers. So that's basically it. That's the entire open source. They sort of create an environment where enthusiastic people who want to change the world, work for free, and they do not realize that they are contributing their time and effort into big corporations that just then exploit them. And then they take all of that free code and they train some sort of model that they create a text editor plugin for, and they sell that free code for $10 a month. So literally what they do, they steal a free code from young enthusiastic developers and literally sell it with a per monthly based subscription. That's literally how it works. I'm not even fucking joking. So yeah. Anyway, I'm sorry. As you can see, I haven't streamed for quite some time. I have a lot of things to say. I have a lot of things to get out of my system. So right. So there we go. What I need to do, so I have a special script that actually sets up the environment. It just adds some things into my path, and the way I usually do that, right? And the way I usually do that is by just doing, I think source, right? OPT Java environment, and then I have Java C, so we should have some programming here. Jesus fucking Christ, that's so many fucking flags. Okay, so let me do Tnux, Python, and what we have to do, we have to Java C main.java. There we go. Yeah, I have to do that one more time. Java environment, Java C.java, and this process is supposed to generate a class file, right? After some time, of course. It's supposed to generate class file, and as you can see, class file is a binary file. It's supposed to be a binary file, right? File utility can even recognize that it's a Java class, but you can then open it with hex edit, and there you go. This is a JavaScript file. So I really like that the magic for this file is a cafe babe. Very funny. You know that? Really? I don't, like in all of the binary formats, there's always so-called magic number, right? There's a magic number for all of the formats. It's just like first, 2 or 3 or 4 bytes, and they usually just identify what type of format it is, right? For instance, if you have some sort of an image, right? So for instance, I'm going to grab some image somewhere here, right? So I'm going to copy paste this thing, wget, and I can probably do lul png, right? So if we take a look, this is lul, and if you do the same thing, hex edit, you will see that the first 4 bytes actually read as png, right? So your PNG has a PNG in the magic. So the executable files of Linux, they have elf and stuff like that, and apparently Java has like coffee babe. All right, so hex edit main class. And the rest of the stuff, I don't really know the rest of the stuff, but there is a lot of like text data in here, which is rather interesting. In fact, it feels like if I open this class file with like a text editor, majority of the stuff here is text, right? So where are the instructions? I suppose the instructions are somewhere down below, somewhere here, and the majority of the files some text, which identifies the names of the classes, the names of the methods and stuff like that, which are not even that important. So why do we even have all of that in here, right? It could have been much smaller, but I don't know. So it is what it is. And by the way, how do you even run this program? You're supposed to use Java. And what's interesting is that you compile this thing with, like that. You say java c main.java, right? You get a class file, and you would expect, it was compiling the entire time. It was actually compiling the entire time, I'm not joking. And you would expect that to run this thing, you have to do something like this. And it doesn't work. You have to do that without the extension. You compile with extension, but if you want to run that class file, you have to do that without the extension. I suppose because Java does not accept the file, it accepts the class name and it searches that class within the file system. It fits some sort of an ideology or logic or whatever. I don't know. So it is what it is. It's Java. Welcome to Java. So people are subscribing. People do be subscribing. Aaron Kornas 2000, thank you so much. Nulagor, thank you so much for gifting 5 subs. Ken Run, thank you so much for the sub. And Nulagor, yet again, thank you for 1,500 bits. Thank you. Just keep in mind that I don't get any of this money. Just keep that in mind, right? Do not go hard on giving me too much beats or too many subs and stuff like that, because I don't get it. And after 8 months of this hell, I don't think I'll ever get them, right? So so Chair Withered, Tsar Jakob, Basil Loves Plant, thank you, Rob Soccer, Brooklyn Dev, Loomis XH, thank you, I really appreciate all that. Maybe I'll get it, but the longer it actually goes, the more I suspect that I just not gonna get anything, right? Because at some point it's gonna be like a tipping point, and who fucking knows? I don't know. How can we pay you? You can't. Don't worry about it. Money is not the most important thing in your life. What's important is knowing how to parse JVM, right? That's what's important. That's way more important than money, by the way. Okay, so this is how you run it, and let's actually try to parse this thing. So I'm gonna go to, I should restart Emacs from within the development environment, so it sort of inherits all of the paths and stuff like that. It's kind of weird that my computer is so slow while I'm streaming. This is really sus. Maybe because it's throttling, so maybe I'm gonna actually it's really hot in the apartment, so I think I'm gonna open the window just to see. So yeah, I open the window so it's not as hot. So because they already That's what happens when you open a Windows on Linux. Yeah, that's true. Oh shit. I can actually hear people outside. So that means they can hear me as well. Maybe you should close the window. It's kind of weird. Imagine right now being in Russia and hearing somebody speaking English out of the apartment. They can think that I'm a Western spy. All right. Anyway, so welcome back to reality. So let me see. Yeah, so I suppose this thing is really throttling right now, so that's probably why it's getting slower. So I can make it maybe throttle less, as if I put something under my laptop, but I have nothing to put under my laptop, so it's kind of weird. Okay. So first thing we need to do, we need to maybe learn how to read the file, right? So if we have some sort of a file path, right? So I'm gonna put a file path as main.class, right? So that's the file that we're trying to read. I'm gonna open that file for reading, right? I'm gonna use the array AI thingy, open as f. 2 pencils. That's actually not a bad idea. Yeah. So, yeah. I have 1 pen. No, I don't have any books. Do I look like somebody who reads books? And imagine reading books in 2022. Come on. I don't quite remember, like, how do you read? Right, so imagine that if I do Python 3, right, and I open the file. Well, first of all, I have an idea. Can I do dir f, right? Which means that it will open the file and just show me all of the things, but it didn't show me them, so maybe I should print this entire thing. Does it have read? Yes, it does in fact have read. And then can I do something like help? So what it will, oh, that's actually very convenient. Right, and I probably can do something like f read, right? So, and read and return up to n bytes. If the argument is emitted, non or negative, read and return all data. Okay, so that's really cool. So I can do something like print the entire thing. Okay, so we got the bytes. So what's the difference between RB versus R in open? This is a good question. So basically, there is this notion in standard, at least standard C library, that when you open a file with fopen, you can open it in 2 modes, right? You can open it in 2 modes. You can open it in text mode or binary mode. So, and open it in text mode makes it sort of aware of new lines, because in different operating systems you have different new lines, right? In Unix you have /n, in right, so Unix is a /n, Windows is /r/n, and Mac OS is /r, if I'm not mistaken, right? So I'm pretty sure all the developers of this operating system did all of that intentionally. So like back in the days when there were text documents, so a text document created in one operating system would have some problems in another operating system. So I'm pretty sure all of that was done intentionally, right? And because of that, like, you had a mode, right? If you open it in text mode, it does something with new lines, but I didn't care about it for so long that I don't remember what exactly it does. So maybe somebody who knows that in the chat can tell you. And binary mode basically doesn't do anything with the new lines, it just gives you the bytes, directly the bytes. As far as I know, these days, it kind of like doesn't really matter, so I would presume B just doesn't do anything, but I put it there as a reflex because I want to read all of the bytes precisely as they are, and just in case I'm gonna open it in binary mode. I don't remember what it does or does not, but the one thing I know is that I need the bytes as they are without any modifications, regardless what those modifications mean. That's why I open in a byte mode. So yeah. So that's the reason why I do it this way. Whether it's correct or incorrect, I don't know. I just want the bytes as they are without any modifications. So just in case, I put B in there. All right. Okay, so we managed to read this entire thing. So maybe I'm gonna wrap this entire stuff into some sort of file, like a read entire file, right? And I'm gonna accept the file path. Oh yeah, so in Python 3 you can actually annotate your functions with the with types, which is rather convenient, right? So they are not checked at runtime, but they act as a documentation, and there are some external tools that can check all this stuff. We're not going to be using them right now, but I'm going to use the type annotation as sort of like a documentation, right? So I think it's a good idea, right? There we go. So it's kind of interesting, like why print was turned from this to this, but the return stayed the same. If you hate print without parentheses so much, why didn't you make it like this? Or does it work like that? I don't know. Like, why? Like, if you want print as a function, why not return that? I'm joking. There is a huge difference between print and return, because print is a legit function and print is a control flow construction, right? So that's probably why you want them to be syntactically slightly different, right? And of course, you have to be able to do it like that, right? Or maybe even like that, right? Anyway. So if I do read entire file, and this is a file path, and if I just run this entire thing, we got the bytes. Okay. So now I can even use slices, right? So I can do something like this and assign it to here, and then just say magic, right? So this is magic equal to magic. Is it equal to magic? Yeah, there we go. So this is magic. It's pretty cool. But I don't really know what the other things mean, right? I remember that in Emacs I can do hexel mode. Yeah, so in Emacs. So what all of that? Like, what comes after this? I have no idea. Java class format. So let's actually Google that. The class file format. Okay, that's cool. So, okay. Oh, there we go. So the first thing is magic, and it's 4 bytes. I suppose I'm gonna assume that U4 means 4 bytes. And the next thing is a minor version. It's 2 bytes, and the next 2 bytes is major version. And then we have some that's a lot of shit actually, and all of that will have to parse. And then we have something like CP info. I have no idea what. Okay, so it's a 1 byte. Okay, so 1 byte tag. Right, so the virtual machine server do not rely on runtime layout classes, blah blah blah. Entries have the following general format. Each constant pool begins with 1 byte tag, indicating what kind of. Oh, okay, so this is like discriminated union of some sort, right? Depending on what is tag, you have different info, and maybe it has different length. That's very interesting, actually. That's actually very interesting. So, and I suppose these are the tags. So you have class, field ref, method ref, interface method ref, string, integer float, blah, 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 blah. That's a lot of different things. And they have different sort of names that are not ordered in any way. There's no 0. There's also no 2 for whatever reason. Maybe there was 2, but they removed it for whatever reason. So that's how it looks like. Okay, so let's actually try to take the minor version, right? So, so this is a magic minor, and it starts from 4, and it's 2 bytes. So 4 plus 2 has to be 6, right? So this is a minor, and we can say minor And let's see what's happening there. So minor version is 0, right? We can actually clearly see that. The first 2 bytes, if we go into hexamod, right? So here are first 4 bytes, and the next 2 are 0. And then the next 2 are 39 in hex. So let's actually try to, read the major version. So this is going to be, I can even do something epic like that. Measure, right, and 6. And then 6 plus 2, what is 6 plus 2? I think it's 8, right? And if we try to read that, it's something like this, 0, 9. Which is rather weird, right? Because it doesn't look like 2 bytes. But anyway, so you know what? We need some sort of a way to actually sort of read the content in advance by the amount of bytes. So essentially, it would be nice to maintain some sort of a cursor, right? So it's initially 0. Right, and then we say something like, okay, cursor is cursor plus the size of the thing we want to read, and after we read that thing, we'll have to add that stuff, right? You know what I mean? Right, so basically like add this thing, and so on and so forth. And it would be nice to sort of like, maintain all of these in some sort of a structure. So I think we need to create like a class, right? Reader. So we get some subscriptions. Apocryphos, thank you so much for the sub. Henry QN, thank you so much. Lumis SH, Feng Chi, Nakonos, thank you. All right, so we need to create the construct. I forgot the name of this thing. I didn't do any OOP for quite some time. I forgot all this OOP stuff, OOP means, right? Constructors, destructors. Some people would even say that constructors are not particularly OOP thing, right? There are different OOP people who believe in different things. In fact, people cannot agree on what is OOP, right? I'm pretty sure, as I said, that multiple people in chat will instantly say, well, obviously OOP is, and everyone is going to say different thing, right? And then these people are going to start fighting with each other, trying to prove that no, OOP is one single thing. Well, in fact, I just demonstrate to you that it's actually people cannot agree on what is OOP. All right. So here we're gonna get the content, right, which is bytes, and we're not gonna get anything else, right? So I'm gonna just assign the content to here, right? So here's the content, and we're gonna maintain the cursor. What's interesting, I think I could have just done that with the file, right? I could have just opened the file and used that as the thing. But I'm not really sure if it's a good idea. Yeah, in fact, I think it's a better idea. Right. So let's actually try to do that. I think that's actually very cool. You can just open it like this, and the file itself already has that cursor that I was talking about. Like it's already built in there. So this is a file, I don't have to read anything, and I can just say, okay, read 4 bytes. So this is magic. Then read 2 bytes, and then read another 2 bytes. This is actually perfect. This makes my life way easier, and as you can see, it works. So another thing I want to do, I want to be able to convert those bytes into numbers, right? So, and I'm pretty sure, I remember like bytes, right? So I can just print it like that, and then I'm gonna exit with 0, right? So this is bytes, right? What kind of methods do we have in bytes, right? What do we have in there? Let's actually see. I remember there was something related to integer, or I think it was part of the int. I think it was part of the int type. Yes, from bytes. From bytes. Look at that. From bytes. And then I can do help. And let me see what we have in terms of from bytes. Return the integer represented by the given array of bytes. You also have to provide the byte order. Right, so let's actually do something like this. Int from bytes, and the byte order, the byte is big, the most significant byte. Okay, so majority of the things of the computers these days like using little endian. By the way, I just realized that I have nothing behind my my camera, so let me quickly put something so I know what you can or cannot see. Right, so there you go. And here, let me see how it works. Right, so we don't need that stuff anymore. Okay, so can I now print that in hex? Right, so what if I want to like print it as hex? Bobby Fecker. Oh, does it use big endian? Big and yes, it does use big endian. Okay, so the bytes of the value are stored in big endian. So is it like that for all of them? Oh my god, this is so slow. So multi-byte data items are always stored in big endian order. Okay, so that's actually very interesting. Sure. So we have to use big. Alright, so there we go. We have a coffee babe. By the way, I wonder, can you just capitalize this kind of thing? Can you actually capitalize that? So is there anything? There's no way to capitalize that, so maybe, yeah, to upper, I don't remember. Anyway, whatever. So int from bytes, big, int from bytes, big. There we go. Okay, so we have a minor version and then we have a major version, 57. That's actually pretty cool. You know, I have an idea. What if we parse the class file as a dictionary? Right. So can I do something like class? It's already taken. Class, right, and this is a dictionary, and we can do something like class. This is the magic, right? And then class. This is how cool kids type. Class major. And then, instead of printing like all of them separately, we can print just the class, right? So show me the class. And it looks like shite, not gonna lie. It kind of looks like shite. So what if I do hex in here? Yeah, boy. Can we do pretty printing? So how do you do pretty printing? Pretty printing. Python 3 pretty printing. There you go. PP print. PP, big PP print. Haha, very funny. Show me examples. So you import, you literally create PP. Okay. Import pprint, and what do we have to do? We have to do PP indent for. Is it really important to do indent for? I'm not quite sure. I'm not quite convinced. Documentation. Show me what you've got. So indent by default is 1. I'm gonna go with the defaults. I'm not sold on indent for, to be fair. I'm really not sold on that. And what do? We just do pprint. Okay, sure. So that means here I can do pprint. Okay, so, and it literally didn't work. Is that because I need like more things in here? Right? Is that, what if I have more? Oh, okay, so I just needed more things in here. And that way it works, and I just like do it like that. So that's precisely what I wanted. It's pretty cool. Let me remove these things. This is not what I wanted. I wanted to just run this stuff. So the one problem I see is that it maintains a different order, right? It just like sorts them in lexicographical order, right? So yeah, it is what it is. Anyway, what is going to be next? Constant pool count. I have no idea what the fuck it is. but I suppose it's the amount of these elements in here minus 1. So I'm not sure if I'm gonna be storing that in a class file, because in Python I can just create a list, right? And list itself already contains the amount of elements in there. But why the fuck is it minus 1? It's so weird. So the value of a constant pool count item is equal to the number of entries table plus 1. Index is considered valid if it's greater than 0 and less than constant pool with the exception for constant value. That is so weird. That is wild. So first of all, it contains plus 1, and second, it's indexed from 1. That is absolutely disgusting. Holy fucking shit. Who came up with this format? Anyway. And it also uses big endian. 2022 big endian. How the fuck is that possible? I don't know. Very true. Anyway, so let me actually do something like this. So we read this thing and let me print some stuff in here, right? Let me print. So constant pool count, right? So I'm gonna actually comment it out and just want to see how many of these things we have in there. Maybe I'm gonna actually put it in here, and then I'm gonna do something like this. There we go. So we have 29. Wait. The file is 414 bytes. What is a constant pool? Why do we have so many of them? What the fuck is that? So, oh, it's a pool of constant. Ah, it's a pool of constants. Remember how I said that it contains shit ton of some text data? Right, so there's a lot of text in here. I suppose these are the constants, and if we take a look at what kind of constants we even have in there, cp info, I'm pretty sure there's some sort of like strings or class names or... Okay, I see. So it's some... That's a lot of like metadata, meta information. So yeah, that's kind of funny. That's kind of funny. Okay, so let's actually try to see. So can I do something like it's supposed to like be one less, right? So in range, constant pool, right? So I have to put this thing in here, and so 28. I suppose maybe I have to do like -1, right? So -1, and each time we'll have to read cp info, and I suppose cp info is the tag, right? So we have to read a single tag. So let's try to do that. So tag, and it has to be a single byte, right? Tag equal tag, and we're gonna exit immediately, right? Because we cannot just read all of the 28 tags, because apparently each entry in that array has a different size depending on the kind of an entry. So the first thing you have to do, you have to read the tag, and after you read it, you know how much the rest of the information you need to read, right? So that's basically what's going on in here, right? So I'm gonna print the tag, right? So here's the tag, and tag is 10, right? The tag is 10, and if you take a look at the tag, 10, it's a method ref. Yeah, there we go. So it's a method ref. And can we find the method ref? Oh, here it is. It also contains tag. Oh, I suppose it's like a union, right? It is like a union, right? So then you have a class index and you have name and type, right? You know what? I want to do the following thing. I want to actually take all of these things and create, you know, variables for them, right? So we're going to put them in here, and all of them are separated by tabs, right? So I'm going to replace this thing with equal, like so, boom, there we go. And furthermore, I'm going to do a little bit of a Emacs magic, so I'm going to do align regex, boom. Isn't that freaking epic? Isn't that freaking epic? So let me try to do the following thing. So we can do if tag is equal to that, we need to parse it as a method ref, right? So we can do something like false is not implemented. Right, so this thing is not implemented, and then here we can do something like unexpected tag, and we can actually print it somewhere here, so we can say tag, and we have to use the F. I don't remember how to use the F strings, right? I don't quite remember how to do that. So let me just try the following thing. Hello. And 69. So will that work? Yeah, it will work. It just works like that. Because I don't remember if you have to put dollar in here or don't. I can't quite remember. So it's like not particularly consistent with JavaScript or something like that. I don't know. Anyway, right. So let me see if it works. Constant method ref is not implemented, and as we know in method ref, where is the method ref? Method ref, we have class index and name and type index, whatever that's supposed to mean. It's a name and tag. Okay, so here I'm gonna just take the entire thing, I'm gonna put it in here. So this is 2 bytes, and the other thing in here is another 2 bytes. Boom. And let me see. So I want to print them, but what I'm thinking is that maybe I have to create something like this. So cp info, right, and it's going to be dictionary, and then cp info tag is equal to that, and then well, this is not how we're supposed to do that. We're supposed to put it like that, and then we just put it like this. And then cp info like so. So we're starting to collect all of these things. Right, we're starting to collect all of these things. And at the end of this, I'm gonna just print cp. Actually, we have to do pp print, right? So we have to do pp print, cp info, and let me see. Okay. So class index and name and type index. And what are they? Class index is a value of class index item must be a valid index into constant. Oh, that is actually very interesting. So the constant also have cross references to themselves within that array through the indices. You have array of constants. Constants have different types, and those different types also cross reference each other, right? So, and in here, I suppose class index, so there is a constant class, and I suppose this index would point at a constant within the constant pool array with the type class. That is actually very cool. But that also creates a pain in the ass to validate, right? So that creates an opportunity for a method referring to a constant that is not a class. So that means you have to not only load all of these constants if you are JVM, right? So if you are JVM, you're not only loading all of these constants, which is already pain in the ass, by the way, as you can see, because they have different sizes and stuff like that. It's already pain in the ass. It would be way better if they have the same size and you can just load the entire file into the memory and just slap some texture onto it and just like quickly find things. It's already pain in the ass to read. But on top of that, you have to validate that certain references point at expected types. So you're parsing, then validating. Why? You could have actually basically take all of the types of different constants and put them in separate arrays. Literally, you put them in separate arrays. And if you are referring to, for instance, class, it's an index within the constant array. So that way you never have to validate it, because like the only thing you'll have to validate is whether it's a valid constant within the available range. Why? This is such a weird format. It's not even particularly convenient to work with. Why would you do that? But I mean, it's old format. All the decisions were made. We don't really know the reason behind this decision. But if I was developing this format, first of all, I would make it so it's easy to just load all of the bytes and reinterpret the pointer to them to some structure. So you don't have to parse anything. The only thing you need to know is just like the structures and stuff. And the second thing I would do, I would separate different kinds of the constants into separate arrays, so you don't have to validate anything. But this is just me. I'm just a stupid Russian, right? I don't know shit, but this is how I would do that? I don't know. What do you guys think? What do you guys think? So for how long I already streaming? I don't really know. Does anyone know for how? I think I already streamed like for an hour or two, but I didn't really feel it that much. But yeah, maybe the time has come. The time has come to make a small break. Right. So the time has come to make a small break and make a cup of tea. Alright. So one of the things, by the way, I want you to do, I want you to convert these tags into, you know, into strings, right? Because if you just like print this entire stuff, right? So this is the magic, and here the tag is just like this, but we're supposed to parse this stuff, so it means we're making it from non-readable form into more readable form, right? So that means it would be nice to actually sort of replace this thing with a tag and then say cp_info tag is equal to this stuff. So then when you try to do that, the tag is this thing precisely, which is kind of cool, is it not? I think it is. It is actually very, very cool. Okay, I wonder if I can do something like cp_info equal, and then just put it like that. You can't do that. You can't just really. Excuse me. Anyway, I wonder if I can do something like cp_info, right? But then I have to not put a new line in there, which is not particularly convenient, right? So how can I do that? And I have to say and equal nothing, right? Yeah, it's kind of sus, not gonna lie. Yeah, but it's doable. Let's put it this way: it is doable. And then somewhere here, I want to do a similar thing, and then I can say class. Right, so we can clearly see what's going on here. We managed to parse the first thing, and then it exited abnormally, but I think it shouldn't exit abnormally now. Alright, so I'm going to put it like that. I'm going to constant pool. Right, so this is a constant pool, and then I'm gonna append that cp_info to the constant pool. That is actually very cool. It's still exited abnormally because I put exit in here. I should have not done that. There we go. Okay, so we have an expected tag, and what? Are you freaking serious? Isn't... Oh, wait, I'm an idiot. So you have to read it in here. So I just saw this thing and I thought the F string didn't render it, but then I didn't realize that you have to move your eyes a little bit down, one row down, and then you will see a rendered string. Of course. I see. Okay. 7. Okay, so what is 7? It's a class. Would you look at that? It's a class. So if elif tag is equal to class assert false. By the way, thank you so much for the subs. Like, I probably missed a lot of subs, and I really apologize for that. Xai2, Ghosty X, Nerdy Pop Rocks, Limis X, thank you so much. I really appreciate all of the subs, even though I don't get any money. I really appreciate the intent. it's really important for me that you guys still like what I do. Cheers, by the way. That's a pretty good tea. All right, so let's continue. Constant class is not implemented. So interestingly, maybe for now, I'm going to print what we're sort of doing in here, but maybe I can put this thing in here. So it is going to happen on each individual entry that we manage to parse, right? Something like that. And also we're gonna uncomment that, and there you go. Right, so this is the CP info, this is the first CP info we got, and the next CP info is a class, and we need to know how to parse this class. So let's actually try to find this thing. So it's info, and what's the structure of this stuff? Okay, the structure of this thing looks like this, and apparently it needs only name index. CP info name index, and name index was 2 bytes, right? So it was in fact 2 bytes. Right, so this is that, and then we can just return that. Okay, so it works. The name index is 4. So we already built a pretty cool machinery, meaning that now if we need to add a new type in here, we just need to add a new elif, and it will automatically like populate this array and stuff like that. So we don't really have to do much, which is rather convenient, right? So I can just like hit rerun, and the next tag is 12, right? So let's take a look at 12. It's a name and type. Name and type. Okay, sure. elif tag. Name and type. Oh, and by the way, so it's quite important to also do this thing like that. Name and type. All right. What else do we have? Is it info? Okay, so it contains name index and descriptor index. There we go. CP info, all of them, both of them are 2 bytes. Maybe I should actually create like a separate function that accepts f and the size and just does all of that for me automatically. That will be actually kind of convenient, I think. Right, so this is the name index, because I would like to do something like parse bytes f2, right? So something like this, or maybe even parse u2 and then parse u4. So because we have predefined types anyway, so that's kind of convenient. I think I should do that actually. So let me quickly do that. What does open return? Right, if I do something like help open, does it return a particular type? It's kind of difficult to tell what kind of type does it return. Because it doesn't tell us, right? With Dex Dalvik, NDNS is determined in the header. Dalvik, it's the Android JVM, right? So I like vaguely remember. I know nothing about Android stuff, but I vaguely remember that it's Android. So in Android, it's determined by header. I don't think it is the case for regular JVM. Because with Google Apps, so this is the official documentation for this thing, and NES, right? So multiple byte data items are always stored in big endian order, where the hide bytes come first. So that's part of specification, I suppose. So yeah, it is what it is. Ah, okay, being BE nice, that makes things simpler. That's a very dangerous thing to say in a chat with a lot of programmers. Anyway, that's a very dangerous thing. It's like saying something about tabs being better than spaces, which they obviously are. You should use tabs instead of spaces because they save memory on the disk, of course. So this has to be parsed to U2F. Okay, so what I want you to know what's the type of open. Is it even possible for me to like find this entire stuff? Python 3 open. Built-in function. So because as far as I know, they're usually annotated. Standard functions are usually annotated, but this one is okay, file object. What is a file object? It's a file like. And I wonder if I can just say, okay, whatever. I think it's a waste of time. Parse U1 is going to be just F, and in here, right, in here, we'll simply return this stuff. I wonder if I can just do it like that. 2, 2, 4, 4. Okay. I have an interesting idea. Can we do a query replace regular expression so it captures the number in here, and replaces it with print u, that number. Boom. Well, that was actually kind of, yeah. You have to do it like that. So this is the call to, it's kind of difficult to see. We have to capture two things. The first thing is this one, right? And the second one is this one. And what we have to replace it with, we have to replace it with parse u1, actually 2, 1, right? We replace regular expressions. So this is the first thing, and this is the second thing. And no, boom, boom, boom. That was actually kind of dumb to do that in here. It should have been done somewhere here. There we go. Cool. Look at that. Look at it go. That's perfect. That's actually perfect, and I think it actually makes it a little bit more readable. Can your beam do that? Well, it can actually do that. But can it do it as conveniently as Emacs? I don't think so. Right, so we have name and type, and everything seems to be working fine in here. So the next tag is a tag number 1, which is UTF-8. Would you look at that? It's UTF-8 one. So tag const UTF-8 cp-info tag UTF-8, and let's see how UTF-8 looks like. Info, where are you? It has a, okay, this one's interesting. Okay, I see what's going on here. So we have to do something like this, right? CP, maybe I even have to do something like length. Parse u2f, so that's the length. And after that, what we have to do is cp-info bytes. Bytes equal read that length. There we go. So that should be the case now. Oh, so this is actually pretty cool. You see, there were 3 const UTF-8 constants in a row. So here's an interesting thing. We have 29 constants. Right, but they are repeating constants. So as you can see, the more constant types we implement, the faster the process of implementing them becomes. Because there's a lot of like similar things in a row, right? So now we just parsed 3 of them simultaneously, and we can clearly see these are some sort of names. Right, so this is the name of a class, of an object class. This is the name of, I suppose, initializer. This is another field or something. And this is the text data that I was talking about at the beginning, right? So the class contains a lot of text, and we're starting to find the boundaries of that text, right? So that's basically what's going on here. Isn't that cool? Isn't that cool? I think it's pretty fucking cool, mate. V is the method function signature. Okay, that's cool. All right. So what's going to be the next thing? So let's take a look. The next one is 9, and it's a field ref. Okay, this one's interesting. So this is a field ref. CP info tag is a field ref, and let's find field ref info. So it's located somewhere here. There's actually several of them in here, but the only thing we care about is class index and name index, which are the same as for the method ref. Right, so we have a method ref and we have field ref, and they have like a very similar structure. So I'm gonna copy paste this code in here. So, and there we go, I implemented field ref. And how many? Yeah, so we're starting to have repeating ones. And look how many fields we already parsed. That's actually pretty cool. I really like that. And as soon as we parse all of them, we'll be able to resolve some of these cross-references. Right. For instance, like here is the field ref and it refers to the class it belongs to. We'll be able to find that class. And the class is located at 8. 1, 2, 3, 4, 5, 6, 7, 8. And here is the class. So this field belongs to this class, and the name of that class is located at constant 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and the class is system. So you can already manually like find all of these cross references. So that's a really weird format, I would say. It has too many moving parts, as already mentioned, right? So what if the class index does not refer to the class? What if it refers to the field? Right, that means you have to validate it first. And this is like additional work that you have to do, and it's like, why do you have to do that work? Right, so it's kind of easy to generate invalid thing. It's weird, but it is what it is. Maybe it is convenient for something. Maybe it's easier to generate code that way, right? Maybe you can create a generator that just piles up the constant all the time and it is easier somehow. I don't really know. We'll see. Maybe as I start implementing some sort of a generator, it will be obvious, but right now it is really not obvious for me why it is the way it is. It's kind of weird. All right, so what's the next thing? So the tag is 8. All right, and it's a string, which is kind of interesting. We have UTF, right? And the string. Like, what's the difference? Why exactly does it have to be like separated like that? I don't really know. But it is what it is, and it isn't what it isn't. So I really like to explore binary formats like that. You know what I mean? It's just like, you sort of like going on an adventure. Right, because I don't really know what to expect in this format. I don't really know what's gonna come after the constant pool. So right now I'm going through the forest of the constant pools, and then maybe I'm gonna encounter another sort of pool. But the knowledge I gained on how to parse the constant pool is gonna be useful to parse another one. Maybe I'll be able to generalize this code. You see, sometimes in programming the problem looks really daunting. Right? It looks pretty daunting, but the more you work on the problem, the faster you sort of go through this problem, because you build up a machinery that helps you go faster and faster and faster. It's like playing, I don't know, like Minecraft or Factorio, right? So, because these games grow exponentially. You spend a lot of time building farms and building machinery that then helps you to move even further, even faster. So it's like exponential growth. It's kind of the same with programming. It's kind of similar with programming. So at the beginning you have a very complicated format and it looks really daunting, but as you start like parsing it byte by byte, slowly, you build up this machinery that helps you to parse it faster and faster, and then you basically parse the entire format. You know what I mean? Because at the beginning we were reading like 4 bytes of the magic. Now look how many things we're reading, right? You know what I mean? It's kind of difficult to explain with the words. But the best analogy I think is the games like Minecraft or Factory or something like that, where you just build up machinery that gives you exponential growth. Minecraft server. I'm really bad at Minecraft actually. I'm a Minecraft veteran, right? I played it. Yeah, I played it a long time ago. I think I was really into Minecraft before it had hoppers, and then I kind of stopped playing it. So it was a really long time ago. So these days they added so many things to Minecraft, like I just opened it up and it was completely fucking different game. It's just like, where is the Minecraft? I remember. What the fuck? It was this blocky simple game and now it's just like, holy fucking shit. What the fuck? I'm too old for this stuff. Hoppers? Yeah. So at some point Minecraft didn't have hoppers. And at that time I was actively playing it. Right? Okay, so what do we have? So constant string. Okay, so info is just a string index. Okay, sure, I can do something like string index. And what is it pointing? Oh, I suppose it's like a string literal. That's the difference between them. So I was wondering what's the difference between UTF-8 and string. Just a second, I need to close my door. I'm a little bit worried. Just a sec. Sorry if it was too loud. I don't want to alert my neighbors. I don't want them to snitch on me. Ellipses 0934, thank you so much for the subs, and everyone who I missed, thank you. Alright. Yeah, so UTF-8 is the data and string is probably string literal, right? So, and it sort of refers to the data that it holds. We can actually check that, by the way. We can actually quite easily check that. So as soon as we implement this thing, right, and we parsed everything, and it didn't I think it didn't even require to implement all of the types, right? So we definitely didn't implement all of them. I didn't implement integer, float, and I already parsed everything. Of course, well, it's kind of bad to not implement like the entire spec. But I think it's actually not, because we're gonna develop a script that can parse that specific file. Why not? We don't have too much time on this stream, right? So we just want to get shit done. So it's totally okay to have an unfinished thing that does the thing you want. Okay, so let's actually take a look. String. Okay, constant string. And it refers to something at index 14. Right, can I do something like 14? And there you go, it refers to hello world. It is the string literal, because hello world is the only string literal that we have in the entire application. This is so cool, holy fuck. So these are all of the constants, and we actually parse them. Right? This is like, we already have a pretty useful utility that can sort of explore the JVM files. So we got the rate from RWX Rob, thank you so much for the rate. Спасибо. I know that you speak Russian, by the way. Очень даже неплохо. So, after we actually collected all of the constant pool, I think we have to add that to the main thing. Right, so this is a constant pool, and I'm going to remove that for now. I'll say that. So class, right, class, constant pool. And I think I also need to put this thing in here, right? So I added the parsed constant pool to the main structure, and this is now how it looks like, with pretty printing and shit. And with pretty printing, it looks horrible. I hate it, but it is what it is. I wonder if some other parameters we can tweak in the pretty printer. Something like this. Let me see. So what other parameters do we have? We have depth, width, compact, and it's false. Can I say that compact true? Oh, right. Is it compact? I don't see any difference. So I don't think we can do much with this entire thing. So frick it. Okay, that's very pogue. That's very poggers. I wonder what kind of stuff we can have in there. So what if I'm gonna add another method? What if I say something like public static void hello, right? And then I'm gonna move this thing in here, and then I'm gonna call the hello, right? And then I'm gonna recompile main.java. Again, we'll have to wait a little bit. Let's just wait a little bit. Okay, so, and then if I run this entire thing, it says hello world. But the file became a little bit bigger, and now if I try to parse it, right, so we should have more of these things. So in terms of methods, right, so we probably have method hello. Yeah, there we go. So this is just a hello. Ah, I see. It's the name of the method, and some of the method revs refer to that name in here. Okay, whatever. Okay, so one of the things we can, for instance, do after we parse the constant pool, we can just iterate class constant pool, right? So, and this is a CP info, right? So we iterate in those things and we just print in them CP info. All right, so this is what we have. And then I can say, okay, I only care about things that are class. Give me the classes. Right, here are the classes. So I think it would be also kind of nice to separate everything. So this is the whole file, and these are all of the classes. Right, and what's interesting is that in the classes we have name indices. Name index. Right, so here's the name index, and this is a name index that we can use within the class constant pool -1 to find their names. Here are their names, and then we can grab the bytes of those things. Here are the bytes, and yeah, then we can say something like print f file path contains classes, or maybe it refers to the following classes. There we go. Maybe we can even pad it a little bit with spaces. There we go. Is that cool? Right. So we extracted that information from binary without using any third-party dependencies. We just read document like specification, and we just extracted that info, and now we can do that. So what's interesting is that, as far as I know, right, so this is the constant. How can we can try to do something like, okay, here is the class and here it's methods. Can we do something like that? Well, that would be interesting, I think. Right, but that means that we have to transform the constant pool. Right, so first we have to collect all of the classes, then we have to find all of the methods and see to what classes they refer. And that way we can rebuild all of these connections and stuff like that. I'm not sure if I want to spend too much time on that, but that's something that you can do. Right, so essentially now we have this sort of like a database. Right, you can treat this stuff as a database and you can make different queries to that database. Right. So JSON dump is a little bit better. I don't know, like I don't want to spend too much time on that, I'm sorry. Okay, so, but maybe we can try that. Python, let me see. So I can import JSON. So what do we have in the JSON? I'll probably have to print. Dump. Okay. So it accepts an object. Okay. JSON dump. So does it work with requires FP? Okay, help. JSON dump exit 0. FP is the second one, I suppose. Okay. JSON dump FP equal std out. Okay. Std out. I think it's sys. All right. Std out sys. So we get something, and JSON object of the type bytes is not JSON serializable. So that means, what do we have to do? So remember that length, we have to convert it to a string. The question is, how do you do that? So we have bytes 69, 69, 69, maybe it's gonna be hex. I'm pretty sure you just can't do str because you have to specify bytes argument 2 must be a string. Okay, Python bytes to string. I don't remember how to do that. Convert bytes to a string. Decode. Okay, that's cool. Where is this shit? So decode, and then we can say UTF-8. And by the way, we know for a fact that this is UTF-8. You don't have to tell us twice about that. It is, you know, guaranteed that it's UTF-8. Okay. Print. Pretty. Okay. Print. As usual. Nothing new. Okay, so what's gonna be the next thing? All right. What's gonna be the next thing? So then we have access flags, and it's actually 2 bytes. All right. Access flags. So parse. How many? It's actually U2. Right. Oh right. Access flags, it's actually 33. So since it's a flags, I think it would be nice to see them as a binary, right? So you can convert that to binary. Access flags, and this is the binary, but we don't really know what those flags mean, if you know what I mean. Right, so let's actually try to decode them. Access flags. All right, so here are access flags. Oh, it's a public final super interface. Oh, okay, so this is like the things, right? So this is actually pretty cool. I think we can try to decode that into like a list of those names. right? That would be nice. Okay, so let's go ahead and do that. So this is the constants, and specifically here, I'm pretty sure I can do something like a boom, boom, a boom. Alright, and then boom. That was actually kind of bad. So now I can replace tab with space equals space. There we go. And then I can do something like align boom. So this is what we got. So on top of that, so we can clearly see, or can we? I'm not quite sure. Are they go in the order? Are they actually going in the order? I don't think they go in a specific order. So let me try the following thing. I just want to see, can I refer to them as indices? Print. And I want to convert all of them to binary. I'm pretty sure this is not what I think it is. Yeah, so they don't really go in specific order. So what I was thinking, that maybe I can turn them into a list of names, and their position in that name will denote what bit it sets, so it's easier to iterate all of that, but I don't think it's gonna work that easily. So essentially, the way I'm gonna parse all of these access flags, I would like to parse access flags. Parse access flags. I'm going to accept flags as an integer, right? And I want to be able to iterate through them. But how can I do that? I can try to maybe turn all of these into pairs. Right. I can try to do something like that. Look at that. A boom, a boom, a boom. Then I can say access flags equal to that. And this should become a name. Then for flag in access flags, and the flag itself is actually name or value, and if flags, so we have to do AND with them, and if it's not equal to 0, right, if it's not equal to 0, that means we have to add it to the result. The result is that result append name, and then we can just return this entire thing. Or if we want to be functional, we can just do it like that. Right, so we can use the least comprehension. And every single CS grad in the chat is fucking coming right now. Holy shit. Oh. I'm sorry. Or does it have to be a single line? I don't know. Okay, so it has to be a single line. I'm not really sure if this thing is going to work. So let me. And this thing is supposed to return a list of strings. Is that how we do that? I'm pretty sure. Okay. So, and yeah, that should be basically it. Let's get rid of that. And a boom. And access flags. Oh yeah, there we go. It's public, and it's super. It's a super public. I have no idea what super means. Why does it have to be super? Treat superclass methods specifically, especially when invoked by the invoke special instruction. The only thing I know, it's a superclass. It's not just a regular class. It's a superclass. Zulu. Alright, so I wonder if I don't know. What if I make it abstract? Can I make it abstract? Will it even compile if I make it abstract? Okay, I made it abstract. Did it change the size of the entire thing? It didn't, because it should have flipped a single byte. Right, so if I try to do this kind of thing, and let's take a look at the access. There we go, there is abstract. We're parsing the flags correctly. Isn't that cool? That's pretty cool. So yeah, we know what this flag means and shit. So far, and this is not a bad format. It's a bit complicated for my taste. I think you could have made it slightly simpler, right? But it's such an old format, like a lot of things depend on it, so it's kind of impossible to change it at this point. But it's not that hard. Like, everything just makes sense so far. Right, so the constant pool, the access flags and stuff like that, it's pretty cool. Okay, so access flag, then we have a this class, got it. The value of this class item must be a valid index. Oh, okay, so that means you can have several classes in here. But I thought, this is so weird, if I add another class in here, foo, right, okay, I added another class in here, it's not gonna go into the same file. As far as I know, it's gonna create a separate file if I try to compile this, I think. Yeah, it created a separate file. It's kind of sus, isn't it? Right, and if I try to parse this entire thing now, right? Okay, does it refer to foo anywhere? It doesn't even refer to foo anywhere. It's kind of interesting. But now, if I change main to foo, what we're gonna have? Yep. So it kind of implies that you may have several classes in here. Oh, I see. So basically it tells you where is the definition. It doesn't really imply that there are several classes in here. Okay, I'm sorry, I'm just an idiot. But yeah. Okay, it's pretty cool. Alright, so this class is just 2 bytes. And superclass, I suppose, is just a superclass. All of them 2 bytes, sure. This class. This class, well, yeah, I should have not copy-pasted it because like it's not a flags. This class, 22. We can do a pretty interesting thing, by the way. We can take class, this class, and take class constant pool, and just query that thing from here. pp print, like so. Look at that. So here is the definition of this class. It has a name index, right? So name index. And right, name index at 24. So that means we can take that name index and just find that name within the constant pool. And the name is main. That's so cool. So now we can create some sort of utility that can tell you the name of the class by its file, and according to Java, the file name should contain the name of the class as well, but that's beside the point. So that's pretty cool. And the same goes for the superclass, right? So here is the superclass. It's that, and we can also know what's the superclass, right? So I can do superclass, and I use the same query, and the name of the superclass is object. That's actually pretty cool. So you can treat this entire thing as the database. We can even extract the bytes themselves, because why not? So this is the bytes. Right. It's pretty cool. So I really like how this is basically database. You just query this database. This is so fun. Right. I really like messing with binary formats, right? It's just like so fun. I don't know why. Maybe I'm just autistic or something. Who fucking knows? Okay, so now we have interfaces. I have no idea what the fuck is interfaces. Maybe like what interfaces this class implements. The value of the gives the number of direct super interfaces of this class or interface type. Okay. So, and as we can see, interface count, it's an array, right? So each value in the interface array must be valid index into the constant pool table. All right, that's very interesting. So let's actually first read this thing. Interface, what is it? Interfaces count. It's a little bit colon here. It's kind of cold. Come on, bruv. It's a little bit slow as well. It's U2. Okay. And let's just print interfaces count. Oh, it's 0. We don't have to do anything. Perfect. This thing does not implement any interfaces, so we don't have to parse any interfaces. Great, I really like that. You know what I'm going to do? I'm going to actually do range interfaces count, and I'm going to just assert false. Parsing interfaces is not implemented, just in case you're going to feed a file that implements interfaces, so it will crash telling that we cannot parse that, right? So I think it's kind of convenient, right? Yep. And after that, I suppose we can do something like class interfaces. Interfaces empty. So, and this loop is supposed to fill this array up, and then we assign interfaces, right? So that way we can just continue. As you can see, we don't have any interfaces, and we don't really care about it right now. What's the next thing? Fields count. Perfect. Okay, let's take a look at the fields count. Fields. Fields count. And we don't have any fields as well. You see, we don't even have to parse anything. Right, so this is perfect. I really like that. It's just like, yeah. Fields count. Assert false. Parsing fields is not implemented. And then class fields. All right. So as you can see, no fields or interfaces yet. Right. We don't really need them. Okay, method counts. I'm pretty sure this one is not going to be 0 anymore, because we have at least 2 methods in here. Okay, so we actually parsed a lot of stuff in here, and we still didn't reach the bytecode itself. That's what's worrying me. So, like, I don't even know how much we parsed, but we parsed a lot, right? So, and like majority of the file is not even the bytecode, it's just the metadata. But that's fine, because we didn't write that much code anyway. So there's also attributes. Very interesting. Parse U2. And let me see, methods count. Okay, so we have 3 methods in here. Cool. Methods for I in range methods. You know what's interesting is that for the constant pool, it's actually -1, but for methods, fields, interfaces, it's actually not. So we don't have to like subtract that -1. Why? It's pretty weird. I don't know. So and class methods. False. Parsing methods is not implemented, so it should fail. Parsing. Yeah. Okay, so method info. Let's find it. Okay. It has access flags. That's actually pretty cool. We already know how to parse those. Okay, so for each method, so I'm gonna actually put this like this. Oh man, and it also has internal attributes. Jesus. Okay. So field methods. So this is the first method. Method access flags. I don't know how to speak, I'm sorry. Parse access flags. And as you can see, we are reusing the function that we built before. This is speaking of the machinery that helps you, you know, parse faster and faster, right? So we encountered that access flag parsing one more time, we can reuse that. It's actually pretty cool. So, and parse u2 f. And in here we can try to print this method, and I'm gonna exit from 0 in here, right? Because it's not implemented yet. Right, so this is the access flag and this is public, okay. So the next thing we have is a name index, right? So this is the name index. There you go. So this is the name index. But we can do something even more interesting, right? We can take class constant pool and take a name of that thing. -1. All right. So, and this is the field, right? So this is the method, I'm sorry. So init, initializer, is a separate method within the bytecode, within the class. We never actually defined it anywhere, but it's there. That's kind of cool, right? And we can also take the bytes. Okay, that's pretty cool. I really like that. So yeah. So this is the name, and then another thing we have is the descriptor index. Right, and descriptor, I suppose it is also something within the constant pool, so we can do descriptor index. And the descriptor, okay, so this is the description of some sort. I don't know what is that supposed to mean, but I actually want to see. But it doesn't really say descriptor index. The value of descriptor must be a valid index. The constant pool entry must be constituted of a valid method descriptor. So method descriptor. A method descriptor is a parameter that in the method. Oh, it contains a type. It's a signature. Right, it's a signature. It tells you what it contains. That's so cool. All right, that is very, very cool. Alrighty, so, and we also have an attributes count. So that means it's another array. We are starting to parse like a nested array. Parse u2 f attribute count. Like so. Okay, so we have only one attribute in here. All right, and we probably need to parse that. Attributes, something like this. For j this time in range. Aren't access flags for methods different from class? I don't know. Why would they be? Method info. Access flags. No, look, here's the access flags. Oh, I think they are different, aren't they? Yeah, they are different. Thank you so much. All right. So that means we have to rename those things, right? So this is more of a class access flags. Parse. Ooh, you know what's interesting? We can say, we can put them in here. So this is an actual value, right? So the actual value of the flag. We can even call it parse flags, right? And this is flags, which is list of pairs of string and integers, something like that. And what we do, we iterate name and mask in flags, and if value and mask not equal 0, we return that name. That way, we can actually have several of those. We can have class access flags, we can have method access flags, right? And we can, depending on which one you supply in here, you're gonna have different things, right? So that's basically what we have. All right. And now I need to get rid of this thing, right? And then I should be able to replace the tab with something like this, right? I think it's fine. Now I'm gonna put it like that, like that, like that. Can your Vim do that? Can your Vim do that? Okay, so method access flags. So if I try to do that, so this is going to be a range. I'm surprised it didn't fail. Right, because we don't have parse access flags. It doesn't exist, but it's still... Oh, because it's not syntactically correct, that's why. Attribute count. Right, assert false. Parsing method attributes is not implemented yet. Winky face, of course. Now if I try to run that, so this thing does not exist because we can only parse the flags. Here's the value and class access flags. There we go. So in here we just parse the flags and then method access flags. There we go. Cool. And let me move this thing in here, like so. There we go. Thank you so much. Alright, so as you can see, it's the same method, we just like supply different descriptions of these flags. Okay, so attribute info. Okay, so each value of the attribute table must be an attribute structure. So each attribute has this thing. Okay, cool. So we're going a little bit deeper. We're going like a tiny bit deeper. So right now we're parsing a class, and within the class we're parsing a method, within the method we're parsing attributes. That's very interesting. Okay, so attribute, right, so this is the attribute, and for the attribute we parse u2 f, and specifically we're parsing this stuff. So then we can do something like print the attribute. All right, so the attribute index name index 26. Right, so we know it's attribute index, which means that we can take this entire thing. Class constant pool -1 code. So are we getting to the actual code of this thing? That's very interesting, isn't it? Okay, so the next thing is the attribute length. So, and we'll have to do something about that, right? Attribute length. And it could be the bytecode, actually. Are we reading the actual bytecode? That's very interesting. We're getting, finally. So I've been streaming for 2 hours. And after 2 hours, we're finally getting to the actual instructions within 500 bytes of file. That's so nice. That's the ultimate Java experience, in my opinion, isn't it? I think it is. Okay, so I'm gonna print the attribute length. So, and I suppose this is how many bytes you have to read, and you have to read 29 bytes. Yes. So many pose in the chat, I really like that. Yeah, so that's how exciting it is. After 2 hours of work, we're finally getting something. That's poggers, my dudes. Anyways, so let me actually read about all of that. So for all attribute name index must be a valid for all attributes. There's so much things to validate. Right, you also have to validate that attribute name index points to one of the available names and stuff like that. Must be valid unsigned 16-bit index into the constant pool. Entry must be constant UTF-8 info, represented the name and attribute. The value of item indicates the length of the subsequent information, but the length does not include the initial 6 bytes that can continue. Oh, well, that makes sense actually. Certain attributes are present as part of the class file specification. They are listed in here. Okay. Oh, here are the attributes. Here are the attributes. That's actually pretty cool. So the code, if we take a look at the code, is a variable length attribute in the attribute table of method code info. A code attribute contains the Java virtual machine instructions. The Java virtual machine instructions. Finally. Holy fucking shit. They're so fucking deep inside. It's funny, a lot of that metadata is so the actual bytecode can be small. Holy fuck. Like, in all fairness, right? So I thought, like, why people inventing WebAssembly when we have like Java or something? Now I understand. I actually worked with, like, a little bit. I wouldn't say I worked with WebAssembly on that level, but I kind of understand how WebAssembly bytecode works, and it's much better than this. Like, holy fuck. Like, WebAssembly bytecode, I think Kolumbiaca can confirm that WebAssembly bytecode is way better than this. Yeah, because I know Kolumbiaca actually wrote like a whole website where he like tested WebAssembly. Could you post the link in the chat, please? Because I think it's actually a pretty cool website. So yeah. All right, so this is the attributes. So attribute length and attribute info, and we can do f read attribute length. By the way, do I still have decode? Yeah, I shouldn't put decode in here. Oh yeah, thank you so much. So yeah, this is basically the website. And yeah, it allows you to explore the WebAssembly code, if I understand correctly. So this is like predefined modules. and this is the structure of their corresponding WebAssembly file. And it just makes a lot of sense, right? So just separate it into these sections, and these sections like correspond to the textual representation as well. I think, yeah, I think they do. And it's much simpler and it makes more sense. So I really like it. Thank you so much. All right. So let me find. So this is the info, and we are printing this entire stuff. Okay, so this is the attribute name index, and this is the bytecode. We're not gonna try to parse that yet, right? I'm gonna try to parse that. And I think what I have to do, I have to just do attribute c append attribute, right? All right. So, and here we're just collecting the attributes, right? And then we need to add those attributes to the methods, right? So here is the method, and then method attributes. There we go, and then we add that method into the class, right? Methods. Well, it's several of them. Okay, and I don't see. Oh yeah, I see why. Because then I have to do methods append method. There we go. This is how many methods we have. That's pretty cool. Right. So, and all of them contain something. Right, we have 3 methods, as you can see. We have 3 methods, and I suppose if we take a look at the original file, the first method would be initializer of the class, and here are the rest of the 2 of them. Makes sense. Actually makes sense. So since we have all of that information, right, we can go ahead and simply iterate it. Method in class methods. All right, and let's do pp print method. All right, let's not print this file. Right, so here are the things. Class. Maybe I should print it. I'm gonna just simply separate this thing by the line. Yep, here are the methods. You know what I want to do? I want to take their names. Right, so name index. So this is the names which we can then look up in the constant pool. Class constant pool. Is it constant? Constant. Yeah. I thought for a second that it may be constants pool. It's a constant pool. I just forgot. Here are the names. And as I already said, the first method is initializer, then hello, and then main. That's actually really cool. So we can actually extract that entire information from here. This is so cool. All right, so let's take a look at the rest of the things. And methods, and then we have attributes. I suppose we have attributes for the methods, and we have attributes for the classes as well. So this is a class attributes. We have to be a little bit careful because the class attributes might be different. Maybe they're gonna be the same, I don't know. Right, so attribute info, parse, it has to be something like U8, U2, F. And let's just print attribute s info. What do we have? We have 1 attribute. Okay, that's cool. For E in range attributes info. What do we have? So wait. Let's go to here. Oh, it's literally that. So that means here we can, oh boy, we can reuse this entire thing apparently. Can we just say, okay, parse attributes. Right, so we're gonna accept f and count. Right, so how many attributes you want to do in range count. So we're already starting to reuse some of the code. See, we're compressing shit. So I'm gonna just put this like that. So this is attributes, this is count, right? So we do this entire stuff, and after that we just return those attributes. Right, so we can move that to separate things. So, and what that means as well is that we can get rid of this entire code and just replace it with parse attributes f, attributes count, like so. Or maybe we can even inline this entire thing, but I'm not sure about the order of this thing, so I'm gonna just keep it like that, just in case. And that should be it. And this also means we can have attributes count, and then just have class attributes parse attributes f attributes count. That's it. So we just reuse the code. Attribute length is not in the dict, it's intentional. You know why? Because length says how much info we have, and info is type bytes, and type bytes already contains its length. There is no reason to put that length into the dictionary, because you can just always do len of attribute info. You just don't need that information because it's duplicated effectively. You know what I mean? So that's why I don't include that, because it's contained within the info. We're parsing the data, meaning that we're turning it into machine readable form, into human readable form. And in human readable form, we want to just like make this like a dictionary that you can explore and poke around, and we don't want to put too much redundant information. We just want to remove the noise. So that's my approach at least. Okay, so what do we get? Attributes info is not defined. We don't have to print anything, I'm pretty sure. Okay, so we have methods, and we also should have attributes, and it only has a single attribute, which I'm actually very curious about. Right, so I'm gonna do 30, and I'm gonna try to pprint class attributes. Right, so these are the attributes of the class, not the method. They're attributes of the class, and I want to take a look at them. Right, for a in here, so it's only a single one, and in here we have attribute index, name index. Right, it's 30. Class constant pool -1, and what do we have? It's a source file, so it has bytes and it's const. Oh, okay. So that's a very interesting. It's a very interesting attribute, I would say. Not particularly useful, but it is what it is. So I suppose that is it. This is the entire class file. We just parsed the entire thing. And we can probably turn this into a function, right? So we can say def parse class file. And here we're going to have a file path, right? Right, so we open file in here, and then at the end of this entire thing we just return class, and then in here we can do something like parse class file file path, and then I can say main class and it works. And I can change in here to foo, right? And foo is a little bit smaller class, right? It has less methods. And now you can actually wrap this entire thing into a library, right? And put it into the repository. I forgot how the Python repository works, or you can post it on Reddit and get shit ton of upvotes. And all that took is 2.5 hours of work, and you have shit ton of likes on the on Reddit, right? It wasn't that hard, right? But now, what's interesting is that, like, why would you reinvent the wheel and stuff like that? But now I understand the structure of the JVM file. I understand the structure of the JVM file. This is so fucking cool. Right, so, and now if I'll need to generate a new file, I just need to take this code and sort of reverse it. Right, so I need to maybe create a function, def generate class file that accepts the class, the dictionary, the class, and the file path, and actually generates the bytecode out of this class file that you create yourself. But maybe it should accept like constant in a more structured way, or maybe, I don't know. So you can basically use this knowledge. This is not just code. This is not just code. This is also a knowledge that we gathered about the class file. And you can reuse that knowledge. You can improve upon this knowledge. You can add more. So code is also the knowledge. That's quite important. Remember that. Or what about Java to WASM compiler? This is actually kind of cool idea, right? We can try to do that at some point. So why not? So that's what Clojure, Kotlin, and Scala do, I suppose. Yeah. So that's pretty cool. You know, I would like to take a look at the actual bytecode, right? So, but to know about the bytecode, I want to take a look at the. I need to find the method, right, where the bytecode of which we want to sort of like parse and explore. I'm gonna try to reduce the amount of you know, garbage in here, and I'm gonna go ahead and simply recompile Java C main Java. Okay, so then I'm gonna run main.py. Main.py didn't do shit, because why? Because I'm an idiot. Right, so let me do main.class. So this is a simplified version of this thing. It has only 2 methods, and what I want to do now, I want to explore that. Method in class methods. Okay, class. This is not what I want. I want to print the method. Okay, so we probably want to take a look at the name index of this thing, right? 25. Class constant pool -1. And so probably, I'm not sure, why do I have pprint? I have some weird shit in here. Here it is. I should have not had that. Okay, so here are the names, right? And then what I want to do, I want to take the bytes of those names, right? And if this thing is equal, for instance, main, I should print that specific method. It didn't really work for some reason. It actually printed all of them, and I don't really know why. Oh, because I'm an idiot, and Python didn't even tell me anything. What a nice language. All right, look at that. So we found a main, and you know what that means? We just implemented a method, something like find method by name, we accept the class, we accept the name, and we can move this entire stuff to here. Right, and name has to be bytes, by the way. Name, and we just return that method. Right, and we can do print find method by name class main. And we didn't find anything. That's very cool. Because it has to be bytes. Yeah, there we go. So we found the method. We can also try to find init. This is initializer. If you try to find something that doesn't exist, right, it will return down, right? And now we can basically take these queries and turn them into methods, and we can properly start querying things. Right. Method overloading is actually a pretty interesting thing. So let me actually see. What if I have two methods in here? Public static foo. So this is that, and another is going to be float one, right? So we're going to overload them by this thing. So Java C main.class main.java. Invalid declaration return to you have to return something. Okay, return 69. I'm pretty sure that in case of function overloading, it's going to maybe mangle them. But we'll see. I'm really sure what exactly is going to happen. Oh yeah, you have to do void. I'm an idiot. What the hell am I doing? I'm already tired, as you can see, so I really apologize for that. Ah! Okay. Alright. Cool. For method in class methods. Method name index class constant pool. Just want to see what kind of stuff we have in here. This is not what I wanted, but I mean it's pretty close. I want you to run the script. Keyword methods. This is very interesting. Oh, I know how it works. I actually know. So it probably distinguishes them by attribute. It's pretty cool. So yeah, thank you for asking that question. That's actually pretty cool. I just didn't know how exactly Java handles overloaded methods, because in a case of C++, C++ would actually generate different symbols in object file, right? So-called mangling, right? And in the name, it would actually encode the signature, so it will overload them by that signature. So I suppose Java takes a completely different approach. It stores the signature in the attributes, right? So because in the attributes we saw those things, right? And stuff like that. Yeah, so it looks at the signature. So in that case, maybe it makes sense to basically return all of the methods, right? So for method, if, yeah. So basically just return all of them. If you're looking for a method with a certain type, just return all of them. Find methods by name, right? Find methods by name, class foo, where it has to be bytes. Yeah, so now we have two of them. Then main. In case of this, we can do main. Can we destructurize this entire thing like so? Main. Yeah, we can. And if I say foo, it will not destructurize, right? So essentially here, I sort of assert that I expect a single name out of that, right? Okay, fair enough. So now we probably have to take a look at the attributes, right? So the only thing we care about here is attributes. attr in main attributes, right? Attr attribute name index. Attribute name index class constant pool code. Bytecode. So I suppose the time has come to move this code into something like find attributes by name, class name bytes, right? And let's just move all of that in here. But we have to do that, I suppose. So we also have to accept the attributes, right? Sure. So class attributes, and there we go. So this is the attributes we're looking at. Attribute name index. If this entire thing is equal to the name, we have to return that. So we can do attr that return. Boom, boom, boom. No. Print find attributes by name main attributes class Bytecode. Why do we have a syntax error? Yep. Cool. We found it. So I suppose you're gonna have only one code thingy there, right? We can also assert that. It's sort of like doing it like that is kind of asserts that we're expecting only single one. It's like unwrapping Rust. You know what I mean? It's like unwrapping it in some sense. It's kind of similar, I think. Okay, so this is the code. And we want to take the info. And this is what we need to parse. This is literally the bytes of the bytecode. Okay, so let's actually explore the bytes of the bytecode. What is so interesting about them? So what's the length? 37. It's not really divisible on anything by anything, which probably means that the instructions have variable length, right? Which is not surprising considering that a lot of things in this file have variable length, right? So this is something that you would expect, I suppose. So code attribute. So let's actually try to... code attribute is variable length attribute in the attributes table of method info. A code attribute contains the Java virtual machine instruction, auxiliary information. So you have to parse this thing separately. Every Java virtual machine implementation must recognize code attribute. If the method is either native or abstract, the method info must not have code attribute. This makes so much sense because some of the methods may not have code, like abstract ones. Yes, that makes so much sense. And you can check that by looking at the attributes or access flags, maybe. Something like that. The code attribute has the following format. So it has an attribute name index. Okay, so it refers back to its name. Max call stack. And it refers back to the attributes. You actually... That is so weird. So you also have exception table. Holy... Oh, here is the code. Okay, so you have the name, attribute length, max call stack, max locals, blah blah blah. But the thing is, it makes sense to parse it from a file, we kind of know how to parse all of this shit from a file, but we have a string. Is it possible to open bytes as file? Python bytes as file. Is there some treat binary data as... Yeah, so that would be actually kind of cool. Is there something I can do about that? String IO. Bytes IO. Yo, this is cool. Did you guys know that you can take bytes and treat them as file? Apparently. I think. Bytes IO class. Binary stream using... Okay, so that's pretty cool. So that means I can actually do something like import IO. And I wonder if there's some examples. So you can... Do you have to close it? I suppose maybe it's closable. Okay. So that means I can just take this entire thing and with code, maybe IO, bytes IO as F, and now I can read this entire thing, right? So I can read like first 4 bytes of it. And maybe even print them. That's convenient. You know what I want to do that? Why I want to do that? Is because I want to extend this... Oh, I can now reuse the same function. I can now reuse parse u1, parse u2, parse u4. I can reuse all of that shit. Alright, so I can do parse u4. Right. That's actually pretty cool, I think. Right. So I'm abstracting away all of that stuff. So, and we're supposed to have like an attribute name index. All right. So let's introduce code. Code. Attribute name index is parse u2 pp print, and it's the same drill, right? So here's the attribute name index, and we can look it up, but I'm not sure if it's actually that interesting. Attribute length. Oh wait. Oh, I think I know what's going on. If you take a look at how we parse the attributes. So here's the attribute index and here's the length. So this is a union. So that means the next thing here has to be max stack. You know what I mean? Right. If we take a look at the attribute info, the first thing contains is attribute name and length. And the first thing in code is name, length. So that means they overlap. So it's a union. So that means the next thing we have to read is a max stack. All right. So that means we'll have to embed the parsing of these attributes into the original parse attributes function, but we can do that later. Max stack. Right now, I want to get to the code. Right. I want to get to the code. Max stack. Okay. So stack 2. I have no idea why is it 2, but whatever. Maybe the amount of variables on the stack. Right. Max locals. Okay, so max locals is 1. And the code length, right, this one is rather interesting. Code length, parse u4, by the way. Right, code length. Okay, so there's 9 bytes of the goddamn code. F read. In fact, this is the actual bytecode. 9 bytes of a goddamn bytecode. Alright. And you know what's interesting? It contains /r. Okay, so let me take a look. Code. Arrays gives the actual bytes of JVM code that implements the method. When the code array is read into memory on a byte addressable machine, if the first byte of the array is aligned on a 4-byte binary, the table switch and a lookup switch will be 4 bytes aligned. Refer to the description of these instructions for more information on the The detailed constraints and the content of the code array is expressed. Holy shit. I will have to probably like ponder upon this paragraph to understand what they exactly mean, but yeah. But that's the code, right? Constants. So how can we know the instructions? Oh yeah, I'm already streaming for more than 2 hours, which is usually unusual for me. So, especially for the first time after a long break. So I don't think I'm gonna continue. Right. So this is the bytecode. Is that cool? I think it's pretty cool. So yeah. I think it would make sense to maybe commit that and publish it for anyone who want to play with that. If you guys want to play with this thing, I'm going to just do the following thing: pprint class. Right. So there we go. So let me remove that. Let me remove that, and let me recompile main Java one more time, just in case. Okay, the license is going to be MIT. Right, so this is MIT license. README. JVM byte code parser in Python. Quick start. Cons. So do you need a? I don't. Yeah. Java C main.java. Right, so you have to rebuild the Java file, but if you don't have a JVM, I'm gonna still commit class file. Right, so optional. Git init. Ready, set, go. Put Python. Okay, so let's create the repo. Oh, okay. It actually logged me out. Okay, so I'm not gonna log in right now. I'm gonna actually, commit this thing later, so it's gonna be available on the Tsoding organization. All right, everyone. Does anyone have any questions? Does anyone have any questions before I go? So I think it was actually super fun. I really enjoyed today's stream. So the format is a tiny bit complicated, but it's doable. When are you streaming next? I don't know. When I feel like it. Oh, you're from the future. I never thought JVM is really that bad. It is kind of meh, but it could have been worse, to be fair. So the fact that we managed to do that within 3 hours is quite impressive considering the enterprise technology. So, yeah. You doing okay? I'm not sure. I think I'm going crazy. So, and I'm gonna be using the streams as a means to not go completely insane. So just to have something to distract me from all of the shit that's going on. So I'm definitely not okay. But that doesn't matter, right? Because that doesn't change anything from the perspective of what I do daily anyway. Alright, so should we stream somebody, anybody? No kettle, no more? Well, I have only one kettle and it's in the kitchen and I don't really want to bring it in here. I don't know, I'm not sure. As long as you continue making streams, I'm happy. I'm happy as well. So finally I have a good internet. hopefully will survive until the end of this year, at least, because I paid until the end of this year for the internet. How did you manage to get Twitch? What do you mean? Twitch is not banned neither by Russian government nor by any country that sanctions Russia, so it's kind of weird, right? So a lot of websites are either withdrawing themselves from Russia or the Russian government banning them. So it's like a clash between two things. It's kind of funny. But the Twitch is neither of those things. So, okay, Illustrator is streaming. She rated us a couple of times, I remember, so maybe we should rate her back. So let's go ahead and do that. Oh, by the way, thank you so much for all of these subs. Thank you. I'm really sorry if I missed anyone. Olks, Rise, Zont48, Math Kruger, Janix69, thank you. I'm sorry if I missed anyone, but yeah. So let's raid. Let's raid Illustrator. Okay, I'm trying to pose myself, but it's kind of difficult. Alright, so did I... raid has been created. Okay, so get ready for the raid, boys and girls, get ready for the raid, and I see you all and next time. Love you.